Hey, what's going on, guys? Let's do this problem right here. The first question is asking a mass m is attached to an ideal massless spring. When this system is set in motion with amplitude a, it has period t. What is the period if the amplitude of the motion is increased to 2a? Now let's see how you can figure it out. Here we have to know that period equation, that is t is equal to 2 phi square root of m over k, right? And from this one you know that period is not dependent on amplitude. So no matter how much you change the amplitude, the period is going to remain the same. So from this one you know the answer is going to be B, right? Because the period is not going to change. Now let's look at the second question. This question is asking a mass m is attached to an ideal massless spring. When this system is set in motion, it has a period t. What is the period if the mass is doubled to 2m? Now here we have to look at the t and m alone. Now let's take the t and m alone. T is directly proportional to square root of m, right? So let's say this is the initial t period. Now if we have, so when they increase the mass by 2m, when they double the mass by 2m, we are going to have the proportionality is going to be t prime is directly proportional to 2m, right? And if I want to write this one in terms of initial period, we can write this one like square root of 2 t naught, right? Because we know that t naught is root m and t prime is square root of 2m, so this is equivalent to square root of 2 t naught. So this is going to be the relationship. Now from this one we know the answer is going to be E, right? And now let's look at the third question. This question is asking, in simple harmonic motion, the speed is greatest at the point in the cycle when the magnitude of the acceleration minimum. So let's analyze this situation. So they are asking where is the speed is greatest. So if you think about a spring oscillating back and forth, the speed is greatest when the object is at the equilibrium position. It's actually in the middle, right? So when the spring is compressed, it has a spring potential which also has a force. Therefore, the middle, the acceleration is going to be minimum. In the middle, this acceleration is going to be minimum. So we know from that one, we know that when acceleration is minimum, the speed is going to be the highest. So from this one, let's look at the equations. The magnitude of the acceleration is minimum. The potential energy is minimum. Kinetic energy is minimum. So the first one is going to be the correct answer. The magnitude of the acceleration is minimum. So in that point, the speed is going to be the greatest. So that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.